Welcome back to another episode. Today we're going to be talking about pre-embedded systems. Basically what you should know before you even touch a circuit. What can we do with these pins? You can wire it to like a little LED, light emitting diode. Small LEDs you see on circuits. We have an LED right over here, for example. Pins on microcontrollers are made to set to 3.3 volts and 0 volts, but they can provide very little current. Remember we said voltage is how much energy you have, that's how much charge is given to each electron, but then the current is how many of these you can let through at once. So those pins on a microcontroller, they can give you 3.3 volts, but they cannot run a motor. They cannot run a large LED. They barely have like enough current to run a small LED. So the current on microcontroller is typically between like, let's say 5 and 10, 15 milliamps. The current is measured in amps. So, and if you look at the data sheet of a microcontroller, it would tell you how much current you can get out of each pin. So you can safely assume it's between 5 and 10 on any typical microcontroller. Now, this voltage coming out, it goes to an LED. An LED is a current device. It lights up through the electrons going across, they're jumping across inside, and they emit light through the LED. Now we need to limit that current so it's safe for the microcontroller to run these LEDs. So let's say this is a microcontroller, and there are pins coming out of the microcontroller, and the software running inside is what's controlling these pins. So let's say this pin is, I've set this pin to an output, whatever that pin might be, and then this pin, I have to connect it to a resistor. That's a symbol for a resistor. A resistor basically converts energy to heat. So it limits some of that energy going across is absorbed by that resistor by converting it to heat. Now, we're talking about very, very little current, very little heat. You're not going to cook off that resistor. You're not going to feel it getting hot, but it is what's in fact doing, converting energy to heat. And then from this side, we're connecting a diode. Now, the symbol for a diode is this. The symbol for a diode, light emitting diode, will just have like a couple arrows up saying that this LED, when electrons go across, it emits light. Now the other side of the LED is connected to ground. Now this is how it would look like on a schematic. Now in real life, ground over here, and there's ground on the circuit. In real life, this will be named like GND or ground, and it's labeled somewhere on the circuit. So your LED is going from the pin, you have a resistor, you have an LED, and that's going to ground, sharing that pin with the rest of the ground. Remember, that's the ground level. That's the reference for everything we have. Everything should be connected to ground. Now, what resistor size do I need here? We said this is 3.3 volts. And an LED, let's say, drops, for simplicity, drops about 1 volt. Each LED, depending on the color, has a different drop. So there's about a 1 volt going through this diode, LED, and then there's about 3.3 volt coming out of the microcontroller. 3.3 minus 1 is what you will end up over here, around the resistor. You will have 2.3 volts. Now, I did some math earlier. Ohm's Law is what is used to convert between resistance and current and voltage. It's a very simple formula, but you don't even need to know the formula. Just search Ohm's Law calculator, and you can just enter the two values, and you will have the third, which in this case, we have 2.3 volts going across the resistor. And let's say on the low end, we want 4 milliamps. And this will give us 500. From this, we need 575 ohm. This is the symbol for resistors, ohm resistor. This is on the low end if the processor can only handle 4 milliamps. If it can handle 10 milliamps, it's 200. At 10 milliamps, it is, let me get this in view so you can see it. So at 10 milliamps, you need 230 ohms. So the values is between 230 and 575, and that's why most circuits, when you're working with like embedded systems, you would see an LED connected to a resistor that is about 330. This is like a middle ground. This is a very common value, and if you're going to work with circuits, you have to have 330 ohm resistors in your drawer. This is something you would need sooner or later for LEDs and for other purposes as well. So 330, this is one thing that you should have. Another one is 10 kilo ohm. We'll talk about this later. This is for pull-up, pull-down resistors. We're not covering that today, but just keep in mind that 330 ohm resistor is what you need. So you would have a 30 ohm resistor, and how would this actually work in real life? Let's get the circuit right here. We have a breadboard. Breadboards are awesome for connecting electronics. So what happens on a breadboard is these pins right here, they're all connected. There's 1, 2, 3, 4, 5 pins in each row. Each 5 are connected across, and these are connected across. These and these are not connected, but each 5 pins are connected together. So if I want to connect this LED, for example, to the resistor, I'll just plug it to, let's say, like this. So now the pin coming from the LED is connected to this pin from the resistor. And then from here, I can stick a wire, connect it to my circuit, and so on the other end. And now I would have a pin, any of these pins, going to the LED, or it doesn't matter, to the resistor first or the LED first. That's not going to change the circuit. The order is not important. So from a pin to a resistor to an LED, and then back to ground, and this is pin over here is labeled ground. Now, one last thing I would like to mention here is diodes are directional. So if you remember what we had before, so microcontroller, resistor, LED, ground. Look at the LED. It looks like an arrow, and it's always pointing to ground. And how would I know which pin is that in real life? If you grab one of the through-hole LEDs, those LEDs that have wires in them, that like not the tiny ones, surface mount, those will be very difficult to work with. If you want to wire these through a breadboard, you would have a longer lead and a shorter lead. The longer lead, let me draw it so you can see it better. So this is the LED. There's a shorter lead and a longer lead. The longer one is the one that should be going to the plus side, where the voltage is coming from. And the short one is the one that's going to ground. So this is ground. So I would have, from here, I would have a wire going to ground. Remember, ground is the negative line, or labeled ground on the circuit. This one is the one that would be going to the microcontroller. So from the micro, I would have a resistor, and in real life, let's say the resistor looks like something like this. And then the resistor is going to the LED, and then the LED is going to ground. Set this pin to an output, set it high, this LED will come on. I hope you enjoy it. We'll see you next week.